All right, so today's lesson is on circle vocabulary and central angles. All right. So the first one, a circle, is the set of all points that are equidistant from a given point called the center. So every point on the circumference of the circle, right, any point you pick out that's on the circumference is equidistant or the same distance from the center point. In this case, the center point of our circle is that point K. A circle is always named by its center point. The circle here would be called circle K. Right? The notation for that would be a little circle and then the letter K. All right, now that distance that we just talked about, right, that every point is that same distance away from the center point, that's called the radius. You might have been familiar with that term. So the radius is the distance from the center point to any point on the circle. The radius is a line segment and will have one endpoint at the center, right? So K here is the endpoint that's at the center, and the other endpoint will be on the circumference of the circle. So this would be the other endpoint of the line segment. When you connect them, it makes a radius. Every radius in the same circle will have the same length. So anywhere I draw a radius in this circle, right? If I know this one is 7 and it's a radius, then this radius would also be 7. All right, our next vocab word, right, is chord. A chord is any line segment that has its endpoints on the circumference of the circle. So both of the segments that you see here go across the circle and they have both their endpoints on the circumference, so they are definitely chords. All right. Our next term you'll probably be familiar with. A diameter is a special type of chord that passes through the center of the circle. It is the distance across the circle, and it will always be the longest chord you can draw in a circle. Right? So here we have a diameter. All right, it's a chord because its endpoints are on the circumference of the circle, and then it's a diameter because it's a chord that passes through the center point. All right, we have to know that it passes through the center point to know that it's a diameter. All right, some special relationships. The radius will always be half the length of the diameter, or you could say the diameter will always be double the length of the radius. All right, so the diameter equals 2 times the radius, right? Or radius equals diameter divided by 2. All right, this term is also probably new to you. A secant line intersects the circle at 2 points. All right, so this is different from a chord because it's a line instead of a line segment. All right, so it passes through the circle in 2 places. Right? You can remember that word secant because it kind of reminds you of the word second, right? Which means 2. So we have 2 points of intersection for a secant line. Right? Our next one is called a tangent line. A tangent line intersects the circle at exactly 1 point. This point is called the point of tangency. All right, if you draw a radius from the point of tangency, right? A right angle is always formed at the intersection, right? So if you take a look at this first diagram, right, we've got a tangent line. We've got a line going on forever in two directions, and it's intersecting the circle at exactly 1 point. So that's definitely a tangent. The other special property we just mentioned, we've got our tangent line, our point of tangency, and if you draw a radius from the point of tangency, you're always going to get that right angle. All right, here's what I want you to do. I want you to pause the video and try and fill in the vocab words according to the diagram, and then unpause the video when you're ready to go over it. All right, let's take a look and see how you did. So the first one is line segment AB. Hopefully you put radius, right? The next segment that we looked at, it's the segment from A to C. Since that passes through the center point of our circle, that's definitely a diameter. Right, next one we're looking at, and I want you to pay really close attention to the difference between these two questions. Right, the notation on this first one, there's just a bar over the letters DG. So we're just looking at the line segment that goes from D to G. So that makes it a chord. But on the very next question, the notation has arrows going both ways, right? That means we're looking at the line that passes through points D and G, which means this next one, the one with the line, should have been a secant, right? EF, right? That is a line as well, and it's intersecting the circle at one place, so this one should have been a tangent. The next question, right, the point C, right, that is the point where the tangent line is intersecting the circle, so we should have said point of tangency, right? Because BC is a radius, we also know that this right here is definitely a right angle, right, because of that property about the point of tangency and a radius. All right, next up, the point B. That is the center point of our circle. All right, let's take a look at H. H says if AB has a length of 7, then AC has to be, that should be 14, right? AC is a diameter, so we know it should be 2 times 7, which is getting us that 14. All right, AC and EF meet to form a right angle. We mentioned that earlier. All right, that is because, all right, a diameter here is just an extension of a radius. So that property about where a radius meets a tangent point still applies. All right, I bet you know this. I want you to recall how many degrees are in a circle. Hopefully you were thinking 360 degrees, right? We're going to use that a lot when we start solving for angles, right? So our next vocab word, a central angle, is an angle with its vertex at the center point of the circle, right? So the vertex right here would be that center point B, right? So we're going to label this angle ABC is a central angle, right? This is an important property. A central angle will always be equal to its arc. So for example, if I know that this angle right here is 60 degrees, then this property we just learned would tell me that the arc from A to C is also 60 degrees because a central angle is always going to be equal to its arc. Right? Next vocab word, a minor arc is any arc that's measure is less than 180 degrees, right? AC is a minor arc, right? You use 2 letters to name a minor arc. So this arc that we just looked at right here from A to C, we would use 2 letters to name it because it's a minor arc. All right. Next vocab word. A major arc is an arc with a measure that is greater than 180 degrees. So on this same circle, I could find a major arc. Let's take a look. If I start at A, and I keep going and going, and I pass through G, and then I stop when I get to C, I can name that AGC, and it would be a major arc. You must use 3 letters when you're trying to name a major arc. Right. So minor is less than 180, major is greater than 180. A semicircle is an arc that is exactly 180 degrees. A semicircle is half a circle, right? You use 3 letters to name a semicircle as well. So for the circle that you see to the right that I'm scribbling on, right, we could say that EFH is a semicircle. Right? Important things to look for when you're dealing with angles and arcs in circles. All right, we still want to remember some properties from our last units. All right, so what would that be? Vertical angles are always equal. We're still going to see vertical angles in our circles. Linear pairs are always supplementary. All the arcs of a circle will add up to be 360 degrees, and all the arcs that form a semicircle will add up to be 180, right? One more detail about semicircles I want you to be on the lookout for. We know that EH right here is a diameter because it passes through the center point B. Whenever you see a diameter, right, you know you've got a semicircle, right? That can sometimes simplify our problems a little bit. So let's take a look. We're going to do the first diagram on 14 together, and I'm going to let you do the second part on your own, right? So for number 14, it specifically reminds us that AD is a diameter, right? So if AD is a diameter, right, we know that ABD is a semicircle, right? All of this, A through B through D, that's a semicircle. So we know because of the diameter that all of that put together equals 180 degrees, right? So the first thing they ask us for is to find the measure of arc AB, right? Well, if we know that all of that's 180, we see we have this 60-degree angle right here. Remember, one of the first things that we learned was that a central angle is going to be equal to its arc, right? So if this is 60, we can do 180 minus 60, and we'll figure out AB, the rest of the semicircle. So 180 minus 60 leaves us with 120 degrees for arc AB, right? Then they ask us for BD, right? That's the arc we found from our central angle, so it's going to be 60. Next up, let's look for angle ACB, right? So angle ACB is this one right here, right? It's a central angle since its vertex is at the center point. So a central angle is always going to be the same as its arc. So this one would have to also be 120. All right. The last thing they ask us for is the measure of arc ADB. Right? Hopefully you notice that this is a diameter, so how much is left for AED? Well, that'll be exactly 180. All right, I want you to pause the video and try the problems in the second set. All right, pause the video and unpause when you're ready to go over these. All right, the first thing that I hope you notice is that it told you GI and JH are diameters. So that means those two are cutting our circle into 180-degree sections. The first thing they ask us for is angle GFJ. Right. So angle GFJ, that's this one right here. Now, if you take a look at this diameter, right, we can see that we have a linear pair, right? So the diameter is a straight line. Here's our ray, right? So the angle adjacent to 140 would be 40, right? Because they are forming a straight line together. So GFJ is going to be 40. Right. Next up, they ask us for the measure of arc GH. All right. Because we know the central angle for that arc is 140, right? Then the arc must also be 140. Right. Next we have arc HI. All right, well, if you take a look, right, at those two diameters intersecting, we actually have vertical angles right here. So that means angle HFI is 40, and since it's a central angle, the arc will be the same. It will also be 40. All right, last thing they ask us for is the measure of arc JIH. Hopefully you noticed that's on a diameter, so that is half a circle. And a semicircle is always 180 degrees. All right, I have a few more examples for you. Right? We're just going to kind of look at that relationship between the radius and the diameter. Right? I want you to try and fill these out. Right? Remember that the diameter is 2 times the radius, or the radius is half the diameter. Try these problems. Pause the video, unpause when you're ready to go over them. Okay, so here we're looking at a radius. So if the radius is 12, the diameter should have been 24. Whereas on the second one, they give us a diameter of 32, so the radius would be 16, half of that. All right, on the third one, they give us a radius of 9, so the diameter should be 18. And on the last one, they give us a diameter of 21, so the radius should be 10.5. All right. Use circle P to determine whether each statement is true or false. All right, let's evaluate these. First one. RT is a diameter. Hopefully you're thinking false, right? RT is not a diameter, but a chord, all right? Its endpoints are on the circumference of the circle, but it doesn't pass through the center point, so that is false. It is not a diameter, right? Next one, PS is a radius. That's true, right? That segment is going from the center point to the circumference. Last one, it says QT is a chord. What do you think? Technically, this is true because it does have its endpoints on the circumference of the circle. So QT is definitely a chord, but you were probably thinking it's a diameter, right? But remember, a diameter is just a special type of chord. So number 3 is not a false statement. It is a true statement. It is a chord. Specifically, it's a special type of chord called the diameter. All right, I want you to try the problems here. Pause the video, give them a try, unpause when you're ready to go over them. All right, for this one, you needed to use definitely the fact that EB is a diameter. So the first thing that we would want to look at, we know that this is 96, right? So AB is the arc for that central angle, so it should also be 96. Right. Now let's take a look at the next thing that they ask us for. They ask us for ACB. So that means I'm going to start at A. I'm going to go till I get to C. And then I'm going to stop when I get to B. So what I want you to notice is that's the entire circle except for 96 degrees. So we can actually do 360 minus 96 to find out the measure of ACB. And 360 minus 96 is 264. All right, and then the last thing they ask us for on this question is AE. All right, for this one, we can use the diameter, right? We see that EB is a diameter, so we know that when we put these two sections together, that should make up 180. So if we do 180 minus 96, that should tell us the measure of AE. And 180 minus 96 is 84. All right, these are our last problems. Pause the video, give them a try, unpause when you're ready to look at them. All right, first thing we're looking for is the measure of arc DAB. So that means start at D, pass through A, stop when you get to B. So what I want you to notice is that's the entire circle except for those two pieces right there. So we can do 360 minus 40 and 80 together, make 120. So DAB should be 360 minus 120, or 240. All right, let's look at the next one. BCA. So we're going to start at B, pass through C, and keep going until we get to the point A. All right, so what we should see here is that that's the whole circle except for that 100-degree section. So this one can be found by doing 360 minus 100, and that's going to leave us with 260. All right, so that is your notes for central angles and circle vocabulary. We're going to do an activity next.